Hello everyone, my name is Thuan, and today I'll be presenting our work, SwiftBrush, one-step text-to-image diffusion model with variational score distillation, done under supervision of Intron at VinAI Research. To begin with, let's have a brief intro about the basics of diffusion models. During training, images are gradually corrupted with noise. Then a neural network is trained to predict the noise added with MSE loss. After that, at inference, a denoising process is repeated multiple times to generate clean images from random noise. However, traditional diffusion models are very slow as they require multiple steps to generate a final image. Here, our goal is to distill these multi-step models into a one-step generator without compromising quality. We only consider Stable Diffusion in this work as it is the most widely used. Interestingly, our motivation stems not from previous diffusion distillation work, but from text-to-3D techniques like Dream Fusion. Given an input prompt, the high-level idea of Dream Fusion is optimizing the 3D nerf using score distillation sampling loss. First, a 2D image of a camera view is rendered from the nerf, which is then added noise and input into the 2D diffusion prior for computing the SDS loss. The gradient of the SDS loss is the difference between the added noise and the predicted noise from the diffusion prior, which is backpropagated to the 3D nerf. Notably, this pipeline can generate 3D models without 3D ground truth, using only a 2D diffusion prior. Therefore, we were inspired to investigate if we can replace the 3D nerf with a one-step text-to-image generator. This turns a technique for text-to-3D generation into that for text-to-image diffusion distillation. However, naively using SDS loss can lead to mode collapse and poor quality outputs, as can be seen from the figure where we sample images with different random seeds and two input prompts, an oil painting of a train, and a photo of a tiger. This prompted us to look for a more effective approach. Recently, there has been a work prolific dreamer that achieves high-fidelity text-to-3D generation by opting for variational score distillation. Immediately, we adopted VSD to overcome the previously mentioned issues of the naive SDS pipeline. Starting from the SDS pipeline, we utilize an additional low-raw teacher to bridge the gap between the student and the frozen teacher. Here, the image generated from the one-step student is added with noise and input to the low-raw teacher, which is then updated with the normal diffusion loss. Also, the SDS loss is replaced with the VSD loss, whose gradient is the difference between the predicted noise from the two teachers. We alternate between updating the student model and the low-raw teacher. Next, I will present the qualitative results of our work. In comparison, the state-of-the-art model at the time, InstaFlow, requires around 200 GPU days and millions of paired image text data for training. However, as you can see, the quality of this model lags behind existing multi-step text-to-image diffusion models. On the other hand, SwiftBrush is trained for less than 5 GPU days using only about 2 million text prompts, without any image data. Despite this, our model produces high-quality images that correctly follow the input prompt. Quantitatively, our model achieved the second-best FID score and the best clip score when evaluated on 30,000 images in the COCO 2014 dataset. Additionally, we outperform all previous work on the Human Preference Score version 2, which as its name suggests is a learnable score trained to match human preferences. In terms of time and memory efficiency, our model requires significantly less resources and computes for both training and inference. Here are some additional qualitative results showcasing the high-quality images generated by SwiftBrush across various prompts. In conclusion, SwiftBrush significantly improves the efficiency of text-to-image generation by distilling multi-step diffusion models into a one-step generator using text-to-3D techniques. For more details, you can visit our GitHub repo at github.com/vinairesearch/swiftbrush. Thank you.